Want to see something cool? All right, not that guy. But still, something pretty cool to show today. This is an Anker Solix X1 install. As far as I know, it's the only do-it-yourself example. But this is something that you can do yourself if you want. This was purchased from offgridsource.com. They have these available in different sizes and capacities, but this is a 40 kilowatt hour example, which is basically 8 of the 5 kilowatt hour module batteries. It's lithium iron phosphate, or LFP. I have 2 of the power modules, which are the inverters. They are 6 kilowatt inverters with a 12,000 watt peak or surge. It is not the most expandable. It is not the most, it's not going to compete with like an EG4 or some of the, really common DIY stuff. But what it does do really well is it is all a UL listed package. It's very thin and narrow. It's attractive, in my opinion. I don't think this is going to be a problem if you install it and you need to sell your house, or it's not going to be one of those DIY setups that's going to draw attention, or kind of be an eyesore, or potentially a problem when you go to sell the house. So show you what I did here. I have the base mounted on a concrete stem wall here, which you can kind of see. I have actually mounted some steel reinforced tube underneath it, because the included kind of base mount is it's fine, but if it's metal, but if it's sitting on a stem wall, it's not really very stable. So this stack represents about 450 pounds, and it needs to be very stable. There are some wall brackets, but they basically just hold the batteries to the wall. They're not really carrying any of the load. So something to be aware of. So, and chances are you might not hit studs on every one of them. I definitely would not trust this to wall mount. So I put some 2 by 3 inch steel tube underneath the mount, underneath the base, just to support it. But if you were sitting flat on concrete, you'd probably be fine. So each of the modules is 5 kilowatt hours. You can kind of see them there. They are about 100 pounds each. They're all metal. They've got a pretty robust coating on them. It's supposed to be good for salt and installs in your coast. It is a little fragile though, I noticed. If you kind of rub on it real hard or it gets scraped, it does scuff kind of easily, which is kind of disappointing, but otherwise been pretty pleased with it. Fit and finish is really good. It seems to be, well built. So I'm gonna get these installed. You guys get to enjoy the time lapse, but they are heavy and it is kind of awkward to get them installed. All right, so there you go, like 5 minutes stacked up. So one of the really nice things about the Anker system here is, I'll take you in there so you can see it, but basically the wiring is very simple. So these modules are technically your traditional 48 volt battery packs. However, Anker uses, I don't know if it's a voltage step up or something, but this entire pack is a 400 volt architecture. So they're able to get away with really thin wires. There is a BMS or a communications cable, but they basically just daisy chain. So up and down, and you'll notice here, I've got one battery that is not installed. That's because I had one bad battery out of my order of 8 here. So Anker was very easy to work with and shipped out a replacement promptly. There's nothing on this side, just some passive cooling fans or vents. That's another nice thing about the Anker system, is it is literally silent. So I've seen a lot of posts about the EG4 stuff where it's really loud or the fans are kind of obnoxious. This thing's dead silent. There are no external fans. You're not getting airflow in and out of the units. It's just silent. So that's really nice. So I've got to get all of these reattached, and we'll join you back when that's done. I would also point out, this is pretty darn easy to assemble. Those are MC4 connectors, so it's just plug and play. It'll probably take maybe a minute or two to do the whole thing. Next step is I've got to connect the ground wires, which those are basically just daisy chain. So you can kind of see here, they bounce between battery to battery. Those are really handy and easy to attach. Basically no crazy wires to torque or connect or put connectors on. They're just standard MC4. They're all included, so you just snap them together. So makes it honestly about as easy as you could imagine. So I'm gonna get those ground wires on and join you back in a minute. All right, those are all installed now. So each one is daisy chained down and all the way down to that last new battery. So the next thing we've got to do is I've got these connector brackets, I guess. They just retain the batteries together, kind of help from stability. I've got to install those. We've got one on each battery on each side. So get those installed. They're just you know, a metal bracket with two bolts. Again, very simple. In case you want to see what one of these looks like. Basically, it's just retaining the battery in case something moves. They're pretty secure between the wall bracket, the base, and then these clips. So, but we'll get those done, and we'll get the inverter installed. Okay, so those are all installed. I've got all those little brackets in on each side, and basically at this point we're ready for the inverter. The inverter in this system sits atop the batteries. Like I mentioned, these are 5 kilowatt-hour batteries, so it gives us 20 kilowatt-hours in each stack for 40 total. So the inverters put out 240 volts, and I'm using 8-gauge Romex here. This runs out to their backup controller, and the backup controller sits right next to the meter. It basically acts as an automatic transfer switch. If you're familiar with the EG4 platform, it's basically the grid boss. Does not have any smart ports, but it does have a generator inlet, AC coupled solar input. You've got support for 2 of the power modules natively. You can add, I think, 6 total, but out of the box, it supports 2 without any extra like modifications. So each of the inverters has 8-gauge Romex, and then there's some communication or CAN communication that goes between that inverter to this one, and then this one onto the backup controller, which sits right next to the meter, which I'll show you that in a minute. But I'm gonna get this inverter attached and show you how that works. The inverters are about half the weight of the batteries, so we're looking at like 50 pounds or so. Still a little bit awkward given how high they are. wasn't terrible. Much easier than lifting like a 18K or a 21K PV. Probably should have had help, but you know how that works. So I modified this a little bit because I didn't want to see any conduits, but basically we've got our line 1, line 2 neutral ground, and then our 2 communication ports there. So we'll get those connected. Those are just push-in terminals. They're not my favorite, but they do work pretty well in this application. But yeah, we'll get that done. The other side of the inverter is basically just your battery connections and your BMS input. So again, those are just quick connects. So we'll get those done, and then I'll show you the outdoor backup controller. So let's get these attached. I think we'll do the ground first. It'd be kind of hard to do holding the camera, so I'm just going to set you up on the tripod. need to double check, make sure I had the phasing correct here. Let's see. All right. All right, so if you guys want to take a look here. So again, very straightforward. Line 1, line 2, neutral, ground. The two communication cables, they have a really good diagram about this, but this one runs out to the backup controller, and then this one goes over to the other inverter. So basically it's inverter 1 connects to this one, and then this one would go to inverter 3, 4, 5, whatever. If you, on the last one, which this is the last one, this runs out to the backup controller. So that's about it. This guy will seal down. There's some, I think, 6 screws, and then that'll be that. So. It's a little tricky, but honestly, the cover is actually decently sized. It's just, you're cramming a lot in there and not a lot of room to work with. So just take your time. It's not terrible. Honestly, once you get the first one in, the rest of them are a lot better. You get one of them to help hold everything. The screws on the far side, they're pretty difficult to reach, so a longer screwdriver helps. This may have been easier if I had just installed the conduits like they wanted me to, but I think this looks a lot cleaner. I'm a lot happier with it. So, it is what it is. If that's all it was, it's not a problem. And that is that. Everything inside is done. So I've got my wiring put back in there. I've got my brackets attached all the way down. On this side, I've got my inverter attached, my brackets, all my wiring is in place, super easy. At this point, I've got a battery switch to turn on, and then I've got outdoor breakers that I've got to turn back on in the backup controller. So why don't we go check that out, and I'll show you what that's about. And there you have it. They're back online. So pretty slick. You get a nice display, shows you current state of charge, and then how much load the house has, and then how much it's pulling from battery. We've got this set up for time of use. We do not have any solar or PV. Basically just doing time of use shifting. We're able to charge these off peak from midnight to 6 a.m. at either 3 or 4 cents a kilowatt hour, depending on the time of year. And then we use that throughout the day. And we avoid our peak rates, which are 27 cents. So that's a pretty big difference. Also allows us to move to a time of use rate or tariff without having to worry about changing our lifestyle. So if we want to run the dishwasher in the middle of the day, we do. We charge the cars after hours, so that's pretty cheap. But anyways, this is an option out there for people that maybe didn't know that it was an option. A lot of these kind of closed systems, you've got to buy from a dealer, or you've got to pay a very expensive install through an electrician. You know, you definitely want to be comfortable with electricity. You know, these were permitted. We did have to have them inspected, which I think most people building in a city with most, you know, jurisdictions are probably going to be in the same boat. A lot of the systems you see online on YouTube, you know, people are throwing systems together. They're not getting them inspected, and that's not reality for most areas. I think if you're way off in the county or in an unincorporated area and you can get away with that, that's great. But for most people, once they try to get them installed in a permitted fashion, in a safe manner, you know, there's a lot of restrictions, and this is kind of the easy button to get something like this installed. So any questions, put them in the comments. I'll be happy to try to answer them. One final thing, I guess kind of misses the point here, but the appeal of these systems is that you can buy these yourself and you can install them. You do have to go through the Anker Solix Academy to make sure you know how they're supposed to be installed, and that you're comfortable with that. But it's something that's very easy. It's like the Enphase Academy or Tesla Academy. It's very achievable. You can do it in an hour or two. It's not bad. Anyways, but the big appeal of these systems is they are relatively cheap. They're not gonna be as cheap as some of the Chinese batteries, you know, Amazon, stuff like that. But again, for somebody that wants a UL listed system that they can get installed themselves and it's attractive, they're pretty competitive. Like I mentioned, I bought these from Off Grid Source. I got the entire kit for just under 16 grand. I qualify for the 30% federal tax credit, so when it's all said and done, I'm just under $12,000 installed. So that's for a 40 kilowatt hour battery system with 12 kilowatt inverter. So pretty awesome in my opinion. So the good option if you guys are looking for something like that. All right, so this is the Anker backup controller here. Essentially, like I mentioned, power comes in from the meter, comes into this box, and then from here it goes on to my main electrical panel. So get it open so you guys can see. So pretty straightforward. I've got 200 amp main disconnect. This is the main overcurrent protection for our house. It was already here on the side of the house. It was just relocated into this cabinet. And then I've got the two power inverters. These are using 35 amp breakers. And then it does have inputs here if I wanted to connect some AC coupled solar or a generator. It's got to be a fairly sizable generator. It's got to support the load of the house and the charging speed of the batteries though. So hopefully they'll add some standby generator support or portable generator support at some point. But this is the general layout. Let's see if I can zoom in here for you guys. But as I mentioned, power comes in here. These are the two inverters, and then neutral ground down at the bottom. So I'll throw some pictures up from when I had this all apart. It's about 10 degrees. I don't feel like taking it apart today, but yeah, you can add PV and generator here if you wanted to. So, and then up at the top is where the that BMS communication connects, and then the internet also is here. So you can use Wi-Fi or Ethernet. We went ahead and ran Ethernet just for reliability. So, but yeah, that's what it is. Pretty self-contained. Yeah, pretty nice cabinet enclosure. Looks pretty tidy.